All right, day 3 of absolute value week. Today we're going to work on absolute value inequalities. We're going to use our little alligator signs. Hope you guys are checking in with your teachers on Zoom. I was actually helping a student yesterday and they said, Mr. Dresser, I ate my homework. I was like, you ate your homework? Why'd you eat your homework? He said, well, because you told me it was a piece of cake. I like cake. All right. How is the graph of f of x equals negative 3 times the absolute value of x plus 5 minus 7 different from the parent function f of x equals the absolute value of x? So a little review on graphing here. We know that the vertex of the parent function will be 0, 0, but what's the vertex of this graph? Well, the vertex will be the opposite of 5, so negative 5, and then the number at the end, which means compared to this graph, it'll have a different vertex, but it also means that it's this same graph, but it's going to be shifted 5 left, and it'll be shifted 7 units down. What about the negative 3 in front? Well, that negative 3 out front tells us that the graph will open down. If the graph opens down, that also means it'll have a maximum. Whereas this one would open up and have a minimum. And then finally, because we have a 3 right here, instead of going up 1 over 1 or down 1 over 1, we're going to go down 3 before we go over. So it'll also make your graph much narrower or stretched. Review of yesterday. If we have an absolute value equal to 2, that means our distance is 2 from 0, which means if we're 2 from 0, we are either at negative 2 or positive 2. So we're going to take what's inside the bars, the x plus 5, and we're going to set it equal to negative 2, and we're also going to set it equal to positive 2, and then solve. So subtract 5 from both sides, and then subtract 5 from both sides, and our two solutions are negative 3 and negative 7. Number 3, definitely a little bit more work than number 2, because the first thing we have to do before we split our problem into 2 parts is we have to get rid of the 2 and we have to get rid of the negative 10. You also might be tempted to think that because it equals a negative, it's no solution. But before we can determine that, we have to get the bars by themselves. So to get the absolute value bars alone, we're going to get rid of negative 10 by adding 10 to both sides. And when we added that 10 to both sides, that actually turned this into a positive. So now we do have the absolute value equal to a positive. We also need to get rid of this 2. And since it's multiplied, we can divide, which means our absolute value is now equal to 3, which means our distance from 0 is 3. So when we split this up and write our 2 equations, we're going to do x minus 1 equals negative 3, and x minus 1 equals positive 3. Again, the key on this problem is don't set it equal to negative 4 and positive 4. You have to get rid of anything that's outside of the bars before you can split it into 2 problems. Once I split it into 2 problems, I just solve, and this one is x equals negative 2, and this one will be x equals 4. 2 solutions. Second warm-up I wanted to do is just a refresher on graphing, since we didn't work on that yesterday. The first and most important thing we find when graphing a linear absolute value equation is finding the vertex. So we know the vertex is the opposite of negative 3, and then the number at the end, so negative 4. So I'm going to place 3, negative 4 on my graph. That is my vertex. The next thing that I have to look at is whether or not my graph should open up or down, and how steep should it be? What will the slope be of the right side of the graph? So the 2 tells me that I'm going to go up 2 over 1 from the vertex. So I'm going to go up 2 over 1, up 2 over 1. I'm now out of room. And then to make a V, I'm going to go up 2 backwards 1, up 2 backwards 1, and I'll continue to do that the rest of the graph. And then I end up with a nice V shape, which is absolute value, opens up because it was positive. It's fairly narrow because our A value was 2, so we went up 2 for every time we went over. And then we have our vertex to tell us that compared to the original, which usually has its vertex here, we shifted right 3, down 4. Domain and range, we haven't talked about that for a little while. Domain is all of the x values. In this graph, since it goes out left and right forever, we can use any x value we want. We could also think about it as we can plug in any number we want for x, and we're going to get a y value. So domain is all real numbers. But the range, if we look at the graph, we notice that the y values, yeah, there's y values up here above 0. We do have 2 y values that are at 0. We have 2 y values at -1, -2, -3. But once we hit -4, does the graph ever go any lower than a y value of -4? No, it never will. -4 is the minimum y value. It's the lowest y value. So our range is that every y value on this graph will be greater than or equal to the lowest point, which was -4. We're really good at max or min. It's the lowest point on the graph, so that's a minimum. And then interval of increase and decrease. If I go to where my line of symmetry would be, which always goes straight through the vertex, which half of the graph is increasing? The left half or the right half? Well, the right half is increasing. So that means my graph is increasing from this x value, which is 3, all the way until the end of the graph. As we move further right, the graph continues to go up. So it will increase from an x value of 3 to infinity. Now the decreasing side of the graph is the left side. So if I go all the way back, as far back as the graph can go, that's going to be -infinity. And as we go from -infinity towards +3, which direction is the graph headed? Well, as we go this way, the graph is actually going down. So it is decreasing from -infinity all the way until our axis of symmetry, which is at x equals 3. So it's going to decrease from -infinity until it reaches the x value of 3. All right, on to today. It's the new stuff. Inequalities, right? We got our little alligators. Whichever side is getting eaten, that is the greater side. It is larger. So in this case, my absolute value is greater than 5. This one, it's eating the 4, so that means the 4 is greater. And if the 4 is greater, that means the absolute value of x is smaller. So this one, we would say the absolute value of x is less than or equal to +4. So we need to be able to read those. We'll give you some Khan Academy to practice kind of the basics of that. But when I'm doing this, I want the distance that I am from 5, I want my distance to be greater than 5. Well, if I wanted my distance to equal 5, where would I go on the graph? Well, I would go to -5, or I would go to +5. That's if we were equaling 5. But this is saying I'm not equal to 5, my distance is greater than 5. So if I want my distance to be further away than these 2 points are from 0, I need to go further away from 0. So if I go to 6, 6 is further from 0 than 5 is. 7 would be further, right? So anything this way will be further or have a larger distance than 5 did. Same thing over here. The more negative I go, the further I am getting from 0, and my distance will be greater than 5 spots away. So there's a lot of answers to this because there are a lot of numbers that have a distance that is greater than 5 spots away. So to show that we have a lot of answers, I can say that every number that is less than -5 will be a solution. -7 is a solution. -300 is a solution. Because those numbers are all more than 5 spots away from 0. Or we have other possibilities. We have any number that's greater than 5, right? If we go to 22 or 5 million or 1,003,000, those are all more than 5 spots away from 0. So we have all numbers that are less than -5, or for this one, we have all numbers that are greater than +5. Those would be our various solutions. Now this one's a little bit different. If our distance is 4 spots away from 0, we would either be at -4 or +4. But this one says we can equal 4, so we can be exactly 4 spots away, which means I'm going to shade in my circle to show that -4 would work, because -4 is equal to an absolute value of 4. Same thing with +4. I'm going to circle it in because +4 is equal to a distance of 4 away. Excuse me. Over here, I left the circle open because -5 and +5, if I plug them in, they would make a statement that's not true. If I plug in 5, is 5 greater than 5? No. So this is not a solution. But any number bigger than 5 was, or any number smaller than -5 was. But since we can equal this time, we're going to shade in our circles. Now the rest of this is we want our distance to be less than or equal to 4 spots away. So we want to be closer to 0 than 4 and -4 are. So if I want to be closer to 0, well, I'm going to go to the numbers that are closer to 0. So like -3, -2, -1, 0, or 3, 2, 1, 0. So all of the numbers from -4 to +4 will have an absolute value that is less than or equal to 4 spots away from 0. The way we write our solution for this is going to be a little bit different. If we have 2 distinct graphs, we're going to write it as 2 separate inequalities. But this graph, it's all connected, right? It's everything from here to here, one section. So we're going to put our x in the middle to represent all of the solutions. And then I'm going to put my bigger number on the right. I'm going to put my smaller number on the left. And I know that my answers or my solutions have to be what compared to 4? Well, compared to 4, these numbers are less than or equal to 4. But compared to -4, our answers are all going to be greater than or equal. So my x is going to be greater than or equal, it's getting eaten, greater than or equal to -4. This is called compact form. You can also think about it, if you put your smaller number on the left and your bigger number on the right, your inequality sign is going to face the same direction the whole time. It's kind of a way to help you remember how to set it up. All right, so that's our solution. Okay, so I'm going to try to explain it a little bit differently to help give you another way to process this as you determine whether your arrow should go away from the points or towards each other. So if we're doing the absolute value is greater than 3, that means that we want our distance to be greater. We want our distance to be more than 3. So Calvin, can you come here real quick? Hustle over, bud. Come on, hurry. So my distance is greater. So if Calvin and I are standing right here, okay, we're 3 spots away. I don't know what unit we're using, but we're 3 spots away. If I want our distance to increase, where do I need to go? I need to get away from him, right? And we're going to go away from each other. Come back. So if we want our distance to be greater, we have to go away, okay? However, if we want our distance to be less than or equal, so if we want the distance between us to be smaller, we're going to go towards each other. Hey, buddy. That was awkward. All right, go back to whatever you're doing. Okay, so if our absolute value is greater, we're going to get away. If our absolute value is less, we are going to come together. So for this one, we're going to start by marking the points that would have an absolute value of 3, which are -3 and +3. I'm going to leave my circles open because we can't equal 3. And then we want our distance to be greater. So we're going to get away. We're going to move away from each other. So instead of having my arrows come towards each other, they're going to get away. We're going to get far away from 0. So we're going to go away from each other. Therefore, our solutions are each of these two separate graphs. This graph is showing all numbers less than -3. Or this graph is showing that all numbers greater than +3. So for example, what's a number that's bigger than 3? 10, right? This is telling me that 10 would be a solution. If I plug in 10, what's the absolute value of 10? 10. Is 10 greater than 3? Yes, of course it is. 10 is way bigger than 3. So that would be a solution. So any number bigger than 3 will work, and any number smaller than -3 will also work. If our absolute value is less than, or in this case less than or equal, that means we want our distance to be smaller. We want to come together. So I'm going to go to the 2 points that have an absolute value of 6, which are -6 and +6. I'm going to put my circles. This time though, we can equal 6. So -6 is equal to an absolute value of 6. +6 is also equal to an absolute value of 6. So those are part of our solution set. But now we want our distance to be less. So since we want our distance to be less, we're going to come together. These 2 points are going to join forces, and everything in between those 2 points will also be a solution. So our solutions are all numbers that are less than or equal to +6, but also all numbers that are greater than or equal to -6. So it's everything in between and including -6 to +6. All right, so the steps we're going to use, this is a lot to read, but if you get stuck on the steps, you can come back to this slide, take a screenshot, and you'll have all the directions. But I'm just going to kind of explain the directions as we go. So the first thing I'm going to do is I'm going to solve it as though it were an equation. So I'm going to ignore this sign right now, and I'm going to solve the equation absolute value of x minus 5 equals 8. When we solve it, we're actually finding the 2 boundary points. So if this said absolute value of x equals 3, we'd be at -3 or +3. That's why I put the 2 boundary points on those spots. This one we have to do a little bit of work to find where those boundary points would go. Right? Just like we did yesterday, we're going to break it into 2 problems. I get x minus 5 equals -8, and x minus 5 equals +8. We're going to solve, add 5, x equals -3, add 5, x equals 13. So when I found those 2 solutions, I found the 2 boundary points. So I'm going to put a point at -3, and then I'm going to go put another point at +13, which would be roughly right there. And so solving it as though it were an equation helps me find the 2 points. Now is where I go back and I look at the inequality to decide, 1, should I shade in my points? And 2, should we go away from each other or towards each other? So when I read this, this says the absolute value is greater. Does it say equal to? No. So I'm not going to shade these in. I'm going to leave them as open circles. But if our distance is greater, that means we're going to get further away. We want our distance to be more, so we're going to get away, right? So to make our distance increase, we're going to get away from each other, which means all numbers that are below -3 will be solutions, and all numbers that are bigger than +13 will be solutions. So once we draw our graph, we can now use our graph to write our solutions. Our solutions are all numbers less than -3, right? So that's that graph right there. Or, according to this graph, we can also have all numbers that are greater than 13. So again, to kind of recap those steps, solve the problem as though it were an equation. Once you find your two solutions, those are the two dots. Use your inequality sign to determine if it's an open circle or closed circle, and then also to determine if you get away or come together. And then once we have our graph, we can use our graph to write our solutions. It's a lot of work, right? But you can do this. Okay, next one. We're going to start as though it was an equation. So I'm going to put equals. With an equation, we always get rid of the numbers on the outside first. So I'm going to add 6, which gives me 3 times absolute value of x plus 2 equals 24. Still need to get rid of that 3, so I'm going to divide by 3. And now that our absolute value is alone, I can split it into the two separate problems. X plus 2 equals, well, if we have an absolute value of 8, we are either at negative 8 or we are at positive 8. So we set one equation equal to negative 8, one equation equal to positive 8. Then we can solve, which gives me negative 10 and positive 6. So what do those 2 points tell me? Well, these are my boundary points. So I'm going to put one point at negative 10. I'm going to put the other point at positive 6. And then I need to look at my original inequality. And this inequality right here says that my distance is less, not equal to. So I'm not going to shade them in. I'm going to leave them as open circles. And if our distance is less, that means to make our distance less, we're going to come together. So these 2 points are going to come together, and everything in between those 2 points will be a solution. So because we have one set of points here, I can write this all as one long compound inequality where my solutions are less than 6 and they are also greater than negative 10. Okay. Let's go ahead and try this one. We're going to set it up as though it's equals. We're going to do 2x minus 5 equals negative 11. 2x minus 5 equals positive 11. Add 5 to both sides. All right, so this is a good review of yesterday or the previous lesson. X equals negative 3. Same thing here, 2x equals 16. X equals 8. So by solving the equation, we found our boundary points. Got a boundary point at negative 3 and a boundary point at positive 8. Then we go look at our inequality to determine open or closed circles. Once again, we have another one with no equal to, so we'll leave these open. And then most importantly, our distance is greater. So if we want our distance to become greater, we need to get away from each other. So we're going to get away. And our solutions, we can now write by looking at the graph. Our solutions are all numbers less than negative 3, or all numbers that are greater than positive 8. Now this one, you have to be a little bit more careful about because our absolute value is on the right side. Not really anything to be too concerned about, but some people might read this and go, oh, 15 is greater, that means we're going to get away. But we always have to read the absolute value first. So if I read the absolute value, this says that my distance is actually less. If 15 is greater, that means the absolute value is less. So if our distance is less, we're going to go towards each other. So again, I'm going to solve it as though it were an equation. Go kind of quick here. I get a boundary point at negative 3. And a boundary point at positive 7. I go look at my sign, it's again not equal to, so I'm going to leave it open circle. And then this is again where we had to be careful. Our absolute value is actually less. So if we want our distance to be less, we're going to go towards each other. And we're going to be everything in between -3 and 7. So our solutions, our x's are representing our solutions, are less than +7, and they are also greater than -3. Write that all as one inequality. All right, so some more practice. First question I'll ask is, will our circles be open or closed? Well, they will be closed circles. They'll be shaded in because now we can equal. Will our graph get away or come together? Well, if our distance is greater, we want to get away, right? But first I'm going to solve it as though it were an equation. So I'm going to set it up with equals. So I do x plus 3 equals -4. X plus 3 equals +4. Solve it. So one solution or one boundary point is -7. And we said this time we can equal, so I'm going to shade it in. Our other boundary point is going to be +1, so that's pretty close to 0 there. And then we said our distance, we want it to be greater, so we're going to get away. So we end up with two separate solution sets. We have all numbers that are less than or equal to -7, or we have all numbers that are greater than or equal to +1. Another example, set up my two problems. 2x minus 4 equals -6. 2x minus 4 equals +6. Solve each one. Sorry if I'm going too fast. I like to go fast sometimes. Just slow it down if you need to. Pause it. But when I solve it, I get that my boundary points would be -1 and +5. This time it's not equal to, so I'm not going to shade in my circles. And then this time I have to be careful to read it backwards because my absolute value is on the right side. And this says my distance is less than 6, or 6 is greater than my distance, which means my distance is less. So if our distance is less, we want to come together, get closer. So it's going to be everything in between -1 and +5. So x is smaller than 5, but greater than -1. All right, we're almost there. I think we can actually skip these two. It's pretty similar to what we've already done. And then this one, we're just going to talk about the concept. We might throw one of these on your homework, but it's not something that we'll probably test you on, just to see if you can understand the idea of inequalities and absolute value together. So this problem says that our absolute value is greater than -8. Well, what is absolute value again? It's our distance from 0. When will our distance, I'm just going to put distance for now, be greater than -8? Well, what do we know about distance? Distance is always positive. So when will our positive number be bigger than -8? All the time. There is no distance that will ever be smaller than a -8 because every distance is 0 or bigger. So this would actually be a solution of all real numbers. How would we show that on a graph? Well, it goes forever that way. Also goes forever that way because we can have any number. No matter what number we plug in, we're going to get a positive once we take the absolute value. And that'll definitely be bigger than -8. So every number would work for this inequality. Now this one says that our absolute value, or our distance, is less than -4. Okay, so a reminder, distance is always positive. When will our positive be smaller than a -4? Is a positive number ever smaller than a negative number? No. So there is no way we could possibly find an answer for this problem. So the solution would be that there are no solutions. No real solutions. So then how do I graph it if there are no solutions? You don't. You leave it blank. That was more so some food for thought. Get you thinking a little bit. Anyway, I know that was kind of a bigger lesson. A lot of concepts in there. Again, the key idea, if your absolute value is greater than, we want to have a bigger distance so we get away. And if our absolute value is less than, we want our distance to be smaller and we get closer. Have a wonderful day. The finish line is near. Keep working. See you later.